students, today in the chemistry day 2 I brought here the chemical equations and its type and to balance the chemical equations. So let us see now. A chemical equation is a symbolical representation of atoms present in a chemical reactions by the symbols of the atoms of the element. Okay, so a chemical equation is the symbolical representations of atoms present in a chemical reaction by the symbols of the atoms of the element. So in a chemical reactions, it may be given in terms of word. So here in the chemical equations, we are going to represent all the names of the atoms by the symbols of the atoms. Okay, so for example, here in a chemical reaction, hydrogen reacts with oxygen to form water. So this is a chemical reactions, and here we are going to represent it into chemical equations. So now let us see chemical equations. So hydrogens, it is, you know, the symbol of the hydrogen is H, but in terms of here actually to exist independently, hydrogens cannot exist alone. So it combines with another hydrogens to form the duplet structure, and here it is stay as H2. If hydrogen want to exist in nature, then it should be H2, not H. Plus oxygen, same thing, oxygen also O2, another oxygen molecule, they combine to form oxygen molecules. Two keeps, that is the arrowhead to be pointing toward the product side, and to form water. Water is H2O. So this is the symbolical representations. Hydrogens by H2, oxygens O2 reacts with, that will be plus to form water. So here in between, these two are called as the reactants. The substance which react together, they are called reactants, and a new substance formed, they are called as the product. So this is the chemical equations. Now let us learn about the types of the chemical equations. Types of chemical equations. So here broadly, here we divide the chemical equation into two types. One is called the balanced chemical equation, another one is the unbalanced chemical equations. Let us see now. The first one is the balanced chemical equations. So the definition is like this. Those chemical equations in which the number of atoms present in the reactant sites and product site are equal. Okay, so here are those chemical equations in which the number of the atoms present in the reactant site and the product site are equal, so are called as the balanced chemical equations. Let us see with example here. For example, here hydrochloric acid reacts with sodium hydroxide to form sodium chloride plus H2O. So this is reactant. Okay, so these are called reactants, and this substance newly formed is called as the product. Okay, so you will know how these chemicals reacts to form the new products. So this we'll learn in the next coming classes, and also for knowing this one you have to go back to the class 9, like I say, to know the atoms, the symbols of the elements, their valency, and also atomic mass. For that one I will make a new videos, and there also you can see, you will know very easily there. So let us proceed now. These are, we can take is the left hand side, no problem, and this are right hand side. Let us see hydrogens. How much? 1 plus 1, that is 2. Here how much? Hydrogen here also 2. Same, right? And chlorine is 1. Here also chlorine is 1. Sodium 1. Here also sodium is 1. What about oxygen? Oxygen also 1. Here also oxygen is also 1. So left hand side is equal to, is equal to right hand side. So here the numbers of atoms in the reactant site and the product site are equal, and it says chemical equations are called as the balanced chemical equations. Okay, now understand, right? So the balanced chemical equations when we write the chemical formula, or you say the equation, here automatically they are balanced. Okay, and now we'll proceed to the another type, that is unbalanced chemical equations. Yeah, so I will change here unbalanced chemical equations. Here also same things. Here those chemical equations in which the number of atoms present in the reactant sites and product sites are equal, right? So here we'll add here are not equal, right? Reactant side and product side will not be equal. So example will be different here. For example, here we take, previously we have taken the equations, hydrogens react with oxygens to form H2O, water, right? So this is an unbalanced chemical equation. How? Let's see. This left hand side and this is the right hand side, right? So let us see hydrogens. How much hydrogen? 2. Here also hydrogen 2, no problem, for the hydrogen is same. What about oxygen? Oxygen is here 2. Oxygen here how much? 1, right? So here left hand side is not equal to right hand side, right? And such types of the chemical equations called as the unbalanced chemical equations. Okay, the question comes that here the chemical equations must be balanced. Okay, so as you know in the class 9 also, by the law of conservation of mass, in chemical reactions the mass of the substance are conserved. That means the mass of the reactant and product side are equal, right? So like that here also the chemicals in any chemical reaction or equations, the number of atoms, okay, the number of the atoms in the reactant side and the product side must be equal. Okay, so we need to balance and unbalance chemical equations. Okay, so we'll learn about how to balance and unbalance chemical equations. Let's see now. here will comes how to balance and unbalance chemical equations. So how to balance and unbalance chemical equations? As we already know that by the law of conservation of mass, here the not only the mass number, that the number of atoms also must be equal. So we are going to balance and unbalance chemical equations. The rules here, some rules are there we have to follow. Okay, before knowing this one, on what principles, okay, so and unbalanced chemical equation are balanced by the law of conservation of mass, right? Okay, so here what method we use to balance it, okay? So the methods to balance is hit and trial method. This is the name of the method that unbalanced chemical equations can be balanced, hit and trial methods. Okay, so here we will learn about some rules. Rule 2, balance, okay, and unbalance equation. Okay, so some certain rules are there. So these rules may not be there in the book also sometimes, but let's just learn now here. So rule number 1, what we'll do, first of all, we will write the chemical equations. If it is given chemical reaction, we'll write the chemical equation. We'll write the chemical equations of the reactions by placing what we have to place. We are placing the reactants in the left and the product in the right side of an arrow head pointing towards products. Okay, so for example, say very simple examples will start, right? So say hydrogens reacts with oxygens to form what, as we know, this one. So first of all, we will convert the chemical reactions into equations first. So this is the first rule to balance. Okay, the first of all, we have to convert, we have to write any chemical reactions into the chemical equations first, okay? And in the next second rules, let us see now. In the second rules, what we'll do now, we will find out the atoms present and compare the left hand side and the right hand side. Right hand side generally are products and left hand side are generally reactant, as we know. So we will compare it. Okay, so just that goes through the example, that one, the simple example that we have to go, oxygen to form this two, right? So left hand side. This is the left hand side and this is the right hand side, right? So hydrogen 2. Hydrogen how much here? Okay, 2. Hydrogen 4, hydrogen 2, 2. Same. What about oxygen? There is 2. Oxygen here is 1. So this is the first things we have to know, that is the comparisons. We have to compare it, other than only the rule number 3 will come, right? So the comparisons don't get confused. And rule number 3 here. Now we will see the less number of atoms. We will see the less number of atoms either in reactant site or in product site. Okay, reactant site or product site, and will multiply the number of atoms we require as coefficients. Or will be there. Okay, so we'll multiply as a coefficients. We'll explain to you, but let me complete the rules now first. Okay, in this example only will go. First of all, or if there is any odd number of atoms either in reactant site or product site, then we'll make it even. We have to, first of all, we have to convert the odd numbers of atoms into the even number. How? By multiplying with an even number. Okay, by multiplying with an even number, we have to convert it, okay, into the even number. Okay, by multiplying with the even number as coefficient, same thing. Okay, as a coefficient we will multiply. See this example first again. Here H2 plus O2 to form H2O, right? In the odd number, 1 will be omit. You know, hydrogen is 2, hydrogen is 2, oxygen is 2, oxygen is 1, right? Okay, so here hydrogen 2, same, no problem, right? Oxygen 2, oxygen 1. That is less number right here. How much we need? We need 2 to make it 2 because there is oxygen 2. So how? We will multiply here as with the 2, then 2 1 are 2. You cannot multiply here 2. Okay, keep in mind. And also you cannot put here H2O2. H2O2, then hydrogen peroxide. This is not water. Okay, it will go another formula. So this H2O is together in the multiply forms, as you know. So these two you will put here as a coefficients. Just like say in the mathematics twice x, you know. Coefficient of x is what? This is 2. Okay, this is the coefficient and this is called variable, right? So this is about mathematics that we know. So like that, this as a coefficient will multiply. Then this hydrogens and oxygen is along with hydrogen, right? So these two is go for the, not only the oxygen, for the hydrogen also. So we will multiply with 2 to the 4. Then what you see here, when we put 2 here as a coefficient, then number of hydrogen is increased to 4, right? But in the left side here we get 2. We have to make it 4 also. So same thing, to make it 4, we 1 by how much we multiply, then you will get 4. That you know definitely, that is 2 2s are 4. Then you will put here. Okay, then now number of hydrogen 4, here 4, oxygen 2, oxygen 2, right? So this is balance. So therefore the balanced chemical equation is 2 plus O2 to give twice times or twice molecules of H2O. So this is how we can balance and unbalance chemical equations. Right, now let us discuss some more examples here, very interesting examples and also very important. So let's see now. So the rules, understand, right? So these 3 rules, that's quite enough to understand how to balance and unbalance chemical equations. Okay, so more example we'll discuss. I will wrap all these things also. Okay, so some more examples we'll discuss. The first of all, say magnesium plus chlorine to form magnesium chloride. Yeah, what you'll do in these reactions or in these equations, will you balance? Is the number same? Yes, magnesium 1, chlorine 2, chlorine 2. You need to balance, because already balance it, you don't need to balance it. So sometimes to make or to check the student's capacity or their understanding, sometimes used to give to balance it, but sometimes used to student get confused. What is this? How to do? But nothing, you don't need to do anything. It's already balanced. Okay, you don't need to do anything. Just leave it. That is the correct answer. Second one, say, let us discuss now some more example. Say nitrogen plus hydrogens to form NH3. So we'll balance it. Okay, so I have some new say methods also, but let us see. Sometimes you may get confused that new methods, that's a little bit short one. We have to play in the mind. But let us learn according to your books first. So here, nitrogen is to compare. Right, at the same time you compare also, no problem. Nitrogen here 1, hydrogen here is 2, hydrogen here is 3, right? Here is less, right? But if you think that as previously nitrogen is 2, nitrogen is 1, if you think that, you will put here 2. Okay, you put here 2, then here also. Okay, but we have to go for the odd number. See here, odd number of hydrogen is coming, right? So just forget about the nitrogens and all. Just think about this odd number. How can you change it into the even number? So we can change it by multiplying with an even. 2, 3 2s are 6 now. Then you put here 2. Then this hydrogen is along with nitrogen, right? So here also you will multiply with 2. 2 1s are 2, right? Then here we already put here 2. Okay, fine. Yeah. Then here we need hydrogen, how much? 6. Then you multiply with 3. 2 3s are 6. Okay, now then hydrogen is already, nitrogen is already 2. Then same. Then here only in the hydrogen only you will put here 2. Then correct answer is N2 plus 2H2 to give 2NH3. Correct? 2, 3, really? This will be 3 ray. Why you make mistake after doing? Yes. So 3 2s are 6, right? We multiply with the 3 only, right? So we have to put. So sometimes get mistake in such case. So you also don't forget, don't confuse in such case, right? Yeah. And number 3, let us see here. Aluminum reacts with oxygens to form. What will form? What will be the formula? I think if you know, if you have the knowledge of the class 9, then surely you'll know. What will be the formula? AlO. What will be? What is exactly the rules? Okay, let me explain you once. Aluminium and oxygens. Aluminium's valency is 3. How to find out valency? You go back to your class 9. At the time only you will come to know. Chemistry chapter 3 and chapter 4. You go revisions at the time you will come to know. Okay, aluminiums, or I'll make the video. 3 and oxygen is 2. As the rule, we cross multiply as you know. Then Al2 O3, am right? Yeah, so Al2 O3. So this is the correct formula of the aluminum oxides, right? Okay, now let us compare. Aluminium 1, how much here? Aluminium 2, wow. Oxygen how much? 2. Oxygen how much? Here is 3, right? In the right side all are more. You may be thinking the aluminum is 2, so you may be thinking you will put here 2 or something like that. You multiply with 2. Yeah, surely you will think, but don't go for that one first. I told you to go for the odd numbers of atoms first, right? So you focus on the odd number of atoms, and this odd number you must try to convert into even. So the first even number is 2, 3 to the 6. Okay, fine. Then just check it again. Next step is you have to, after doing this one, you have to see this oxygen is with whom? With aluminum. So the coefficient, how much you multiply, this you will multiply with this aluminum also. So 2 to the 4, right? So here you put here 2, right? So see in the oxygens, oxygen and aluminum are separate, right? No problem. Oxygen here is 6, so we need 6. 3 to the 6. We put here 3. Fine. Oxygen, aluminum 4. Here is 1. So into 4. For 1 to 4. You put here 4. Aluminum 4. Aluminum 4. Right. So 4Al plus 3 O2. 2 gives twice Al2 O3. This is the formula. That is the correct chemical equations of the aluminum react with oxygen to form 2 molecules of the aluminum oxide. So this is the correct balancings. Yeah, and some more interesting. Let us go. We'll not go for more. You have the many other questions in your book, so you can practice with that one. And if you have any problem, then you can comment, and I'll make you some videos to solve all those questions and all. If I solve all those questions, it will take a long time, so I'll explain the inside content. Or if you need, you give me comments, and you send me personally in my email ID also, and I will make the videos, no problem. So but 2-3 we'll discuss some contradictions used to come. In such example, say another example, same like that type, only say methane CH4 burns in oxygens to form carbon dioxide plus water molecules. Yeah, this carbon 1, hydrogen 4, hydrogen how much? 2, right? Oxygens 2, and oxygen don't ever try to write together, because in the product side or in reactant side, oxygen 2 times in different compound it's present, then you have to write separately. Oxygen is 2, another oxygen is 1, right? Yeah, this is must. See what you see here: carbon, hydrogen 4, hydrogen 2, oxygen 2, but oxygen in this case 2 plus 1, here it become how much? 3, right? It becomes 3. So this is odd. Okay, so what you have to do is that you will, where you get odd number here, this oxygen, right? You will multiply with the even number 2 here. Fine. So I multiply here also 2. 2 1s are 2. Forget about others. And then just check it. This oxygen is along with whom? Hydrogen, right? So here also you multiply with 2. 2 2s are 4. Fine, no problem, right? and then here hydrogen number is automatically 4, here also 4, right? Oxygen 2, right? But here 2 plus 2, how much? It is 4, right? Then oxygen here single 2, right? So you will multiply with 2, 2 2 is 4, then you will put here 2. What about carbon? Carbon 1, carbon 1. So therefore the answer says 4 plus, okay, 2 O2 to give CO2 plus 2 is 2O. Okay, so this is the equations how we can balance the different chemical equations, whatever the types of the chemical reactions or equations that you can balance by this way. It's very simple. If you have any problem, you can ask me. So as a home task, you can do by yourself. I am giving you some examples. Say C2, it's 6 plus O2 to form CO2 plus H2. Same equations, okay, with all those things, but the product is same, but reactions are different. And another one, C3, it's actually this is the ethane. This is methane, this is ethane, this is the propane. C3, 8 plus O2 to give CO2 plus H2O. Okay, so all these things you do as a home task. Okay, so I hope you can do it. If you can't, give comments and also for it. Thank you. And we'll proceed to the next class about the types of the chemical equations now. And I mean the chemical reactions. Equations are really dense, right? Types of the chemical reactions. Thank you.